How is everybody doing today? Got another video for you. This is business calculus, area between curves and average value. So we've got a couple examples of finding the area between curves, and we've got a couple of application problems, word problems. So let's go ahead and get started. So we're going to start out with area between curves. So let's just kind of disregard this example real quick, and let's just do something real simple. Right off the bat, I'll just work it here. So this problem that I'm fixing to work is not this problem. We want to find the area. So if you want to find the area under the curve y equals x squared from x equals 0 to x equal, let's just say 2. Okay, so to find the area under the curve, basically what you want to do is you want to kind of sketch these graphs. So if we sketch the graph of y equals x squared, it's just a parabola, vertex at the origin, opens upward, and here's 0 and here is x equal 2. So we are looking for this area right here. So the way to do that, the area, we're going to integrate our function y equals x squared from 0 to 2. Okay, from x equals 0 to x equal 2. And this would give us 1/3 x cubed. So we know how to integrate now. We just add 1 to the exponent, multiply by the reciprocal of your new exponent, and that's going from 0 to 2. And so this would be 1/3 times 2 cubed minus 0 cubed, which would be 8/3. And that would be the area under the curve. All right. So basically what we're doing is we're integrating the function, and we're evaluating it from some number x to some other number x here. Okay. So that's just a very basic example. When I wrote up these notes, I did not write up a basic example. And then later on, I decided, well, I want to do that, but I didn't have room because I had already written the notes up. So that's what we're doing. So let's look at this one. It says find the area of the region R enclosed by the curves y equals x cubed and y equal x squared. So we have two curves, and we want to find the area between them. All right. So to do that, we want to sketch the graph. So let's sketch the graph of y equals x cubed. That's that one. This is y equal x cubed. And then we have the graph y equals x squared, which is this one. This one's y equal x squared. They're going to intersect up here. And this is the area that we want to find. Okay. So let's just kind of highlight this y equals x squared. Let's just kind of highlight that in red so we can kind of tell the difference between them. Okay. So this is your graph y equal x squared right here. Now, whenever we're finding the area between two curves, it's the area is the integral of the curve on top. See how x squared is on top? Minus the curve on bottom, x cubed dx. Okay, so let me come down here and just kind of explain this to you. So here is x squared. I'm going to draw this exaggerated, and here is x cubed. Okay, they're going off this way, and they're going to end up intersecting up here. I'm going to have to kind of draw this in there. Okay. All right. So basically what we're doing, think about it this way. If we found the area under this curve right here, Okay, just forget about this red one, this red line. If we found the area under the curve, it would give us this entire area right here, right? And then if we found the area under this red curve, that would give us this area. So what we're doing is we're taking this entire area that's green and we're subtracting off this area that's red. And that would leave us with just this part right here. Okay, let me do that in a different color. We would be left with just this area right here. And so that's the idea behind it. So whenever you're finding the area between two curves, it's the curve on top minus the curve on bottom. And you can see that we're going to integrate. Of course, they intersect here at 0, and then they intersect here at this point right here. So we've got to figure out where these curves intersect. Well, how do we do that? Well, we take the two curves and we set them equal to each other and solve for x. So that's x cubed minus x squared equals 0. Factor out x squared. And so that's going to be x squared equals 0 or x minus 1 equals 0. So x equals 0 or x equals 1. And so we're going to integrate this from 0 to 1. All right, so now let's integrate. So that's going to give us 1/3 x cubed minus 1/4 x to the 4th, and we're going to integrate from 0. We're going to evaluate it from 0 to 1. And so this is going to be 1/3 times 1 cubed minus 1/4 times 1 to the 4th minus, and then that's going to be 1/3 times 0 cubed minus 1/4 times 0 to the 4th. Now remember, when you plug the 1 in, that's right here, and then minus, and then you plug the 0 in, make sure you put all of that in a bracket because it's minus that whole thing. And here, that's right. It doesn't make a difference because this back here is just 0. Okay? And so then when we evaluate this, we have 1/3 minus 1/4, which is 1/12. And there's your solution. All right? All right, let's look at another example. All right. So for this example, let's sketch our graphs. We've got y equals 4x, and we've got y equal x cubed plus 3x squared. So let's sketch the graph. So this graph is going to look like, it's going to look something like this. So this is y equal x cubed plus 3x squared. And then we've got the line y equals 4x. That's just a line that goes through the origin. This is our y equals 4x. And so basically what we're looking for is this area right here. Okay. Now let's just highlight one of them in a different color. Kind of go over it. So there's the line y equals 4x, right? All right. Now, you might be asking yourself, well, how did he know how to draw that graph, that y equal x cubed plus 3x squared? You might be thinking to yourself, I didn't know that's what that graph looks like. And you may be asking me, well, how did you know what that graph looked like? Well, because I looked at a graph of it and copied it. All right. So obviously when you take a test, you're not going to have anything to look at to graph these things. So how do you know how to sketch this graph here, x cubed plus 3x squared? Well, do you remember back earlier in your business calculus class, or whatever calculus class you watched? If you're not taking business calculus, you're in another calculus, you learn this too. So remember this: critical numbers, increasing, decreasing, relative max, min, concavity, inflection points. That's what you would have to do. Okay, you would need to go through all that to sketch that graph. I'm just not going to do it in the video, okay, because you know those problems take a little while to work. But yeah, that's what you would have to do. Now, would your teacher give you a problem like that on the test where you had to do that? If you're in my class, probably not. I would give you something that I would expect you to know how to sketch. Now, some of you may have teachers that are real mean and give you something like that. So now you know that's what you would have to do. All right, so let's do the area. So the area is equal to the curve on top minus the curve on bottom. But we got a little problem here, don't we? Here, you see in this part right here, this curve right here is on top. The x cubed plus 3x squared, that's on top, and the 4x is on bottom. But once we get to this point right here, the curve 4x is on top, and the curve x cubed plus 3x squared is on bottom. So the curve on top and curve on bottom change right here. So we're going to have to set up two integrals. We're going to have to set up an integral for this area, and then we're going to have to set up another integral for this area, and then we're going to have to add the two together, the two areas together. And so on our first integral, we're going to have to integrate from here to here, and on our second integral, we're going to have to integrate from here to here. So how do we know what those points are? Well, that's where we set the two equal to each other. X cubed plus 3x squared equals 4x. We set them equal to each other and solve. So x cubed plus 3x squared minus 4x equals 0. Factor out x. X squared plus 3x minus 4 equals 0. So x times x plus 4 times x minus 1 equals 0. So x equals 0, or x plus 4 equals 0, or x minus 1 equals 0. So here x is negative 1. That's a plus sign. X equal 1. So they're going to intersect at negative 4, 0, and 1. Okay, so for our first integral, that's the integral negative 4 to 0, and it's the curve on top, which is x cubed plus 3x squared minus the curve on bottom, the 4x dx. Okay, all right, so let me do this. Let me take this, move it over here, and then let's just kind of move this over a little bit so we'll have some room. All right, plus the integral. Now we're going to integrate from 0 to 1, 0 to 1, and it's the curve on top, the 4x, minus the curve on bottom, x cubed plus 3x squared, and that's got to be in parentheses because it's minus the whole thing, dx. Okay, so let's just kind of rewrite this again. That's going to be negative 4 to 0 of x cubed plus 3x squared minus 4x dx plus 0 to 1. I'm going to distribute the negative. Negative x cubed minus 3x squared plus 4x dx. Okay. All right, so basically what I'm doing is I'm integrating this one, and then I'm going to add the two numbers together. All right, so let's see. So we've got 1/4 x to the 4th plus x cubed minus 4x squared from negative 4 to 0. That's integrating each one of those terms. We add 1 to the exponent, multiply by the reciprocal of your new exponent. Plus, and then for this one, we've got negative 1/4 x to the 4th minus x cubed plus 2x squared, and that's from 0 to 1. All right. So now we got to plug all this in. So that's going to be 1/4 times 0 to the 4th plus 0 cubed minus 4 times 0 squared. Okay, minus, and now it's minus the whole thing, so we plug the -4 in. So that's 1/4 times -4 to the 4th minus, oh wait a minute, no, plus, I was looking over here, it's over here, plus -4 cubed minus 4 times -4 squared. Okay, so that's for this first one here. Plug the 0 in, plug the -4 in. Plus, I'm going to have to come down here because I'm running out of room. Now we plug the 1 in. So that's going to be -1/4 times 1 to the 4th minus 1 cubed plus 2 times, oh wait a minute, let's see, did I mess up somewhere? I did mess up, look at that. So when we integrate this one, so I've got 1/4 x to the 4th plus 3x squared minus 2x squared. When I integrate the 4x, I don't know what I was thinking. Okay, so that, and then that 4 right there should be a 2 also. And this 4 right here should be a 2 also. Okay, all right. Now we're good. Okay. Sorry about that. This stuff, it just all gets jumbled up, doesn't it? All right, so we plug the 1 in. Okay, we plug the 1 in to here, and then plus 2 times 1 squared minus, and now we plug the 0 into here. Now, watch this. We plug the 0 in. So when I plug the 0 into there, that's just 0. Okay, everybody see that? That's just 0. And so then for our answer, and I'm not going to go in and write all this, simplify this by hand or anything, plug that into your calculator, and you're going to get 32.75 as your answer. All right, and there's your answer. There it is. Sorry about the mess up, but you know, it happens. It happens. All right, so just to recap real quick, we worked that simple when I erased it, but just remember, it's the function on top minus the function on bottom. This one, the function on top and function on bottom changed. So it's function on top minus function on bottom plus the function on top minus the function on bottom. Just what we did here. Okay. All right, let's see what we've got right now. All right, so it says, suppose that t years from now, one investment will be generating profit at the rate of P1 prime of t, which equals 50 plus t squared $100 per year, while a second investment will be generating profit at the rate of P2 prime of t equals 200 plus 5t $100 per year. How many years does the rate of profitability of the second investment exceed that of the first? Okay, so that's part A. Part B, compute the net excess profit for the time period determined in Part A. Interpret the net excess profit as an area. All right, let's look at this. All right. So for Part A, well, there we go. So for Part A, the rate of profitability of the second investment exceeds the one of the first until P1 prime of t is equal to P2 prime of t. So we're going to set them equal to each other and see where they intersect. Okay. All right. So you know, basically what you've got here, if you just kind of looked at the sketch of these, it would look something like, maybe something like this. Let's see. That's what the graphs would look like, something like that. Okay, so this would be your P2 prime, and this would be your P1 prime. And you can see that it exceeds it until we get to this point right here, and then this bottom curve would be larger. The P1 would be larger. So we need to figure out what that point is. And how do you do that? Well, you set them equal to each other and solve. So let's see, we have 50 plus t squared is equal to 200 plus 5t. So we're going to subtract 200 to both sides and subtract 5t to both sides. So that's going to give us t squared minus 5t minus 150 equals 0. And so we've got t, let's see, was that minus 15 plus 10? So t minus 15 equals 0, or t plus 10 equals 0. So t equals 15 equals 15, or t equals negative 10. And obviously we won't have the negative number, and so our solution would be 15. Okay. All right, so now it says compute the net excess profit for the time period determined in part A. All right, so I didn't have anything written down here, but the net excess profit, let's see if I can kind of squeeze it in here. There's a formula. Let's kind of just divide this up. There's a formula that says the net excess profit is equal to EN minus E0, okay, which is equal to the integral 0 to n of E prime t dt, which is equal to the integral 0 to n of P2 prime of t minus P1 prime of t dt. Okay, so you can see basically what we're doing here is we're finding the area between two curves, aren't we? Look at this. See, we're finding the area between these curves right here. We're going from 0 to n to where they intersect here, which this is the 15 right here. You see that? That's the 15. And we're going from 0, and we're looking for this area right here. That's our net excess profit. Okay? So let's go ahead and work this. So we've got the net excess profit is equal to E of 15 minus E of 0. See, we got the 15 from part A, which that is equal to the integral 0 to 15 E prime t dt. See, I'm just following this formula here that I have. And so this is going to be 0 to 15, and that's going to be P prime, P2 prime of t minus P1 prime of t dt, which is equal to 0 to 15, all right? And then that's going to be what? P prime 2, which is 200 plus 5t, 200 plus 5t minus P1 prime of t, which is 50 plus t squared. So that's minus 50 plus t squared. And then that would be dt. And so we're going to have 0 to 15. And that's going to be 200 plus 5t minus 50 minus t squared dt, which is 0 to 15. Now, you know, what order do you write these in? I just like to write it in descending powers. Say we got 200 minus 50, that's the 150. I just wrote the minus t squared first. Okay. All right, so now let's integrate. So we've got negative 1/3 t cubed plus 5/2 t squared plus 150 t, and that's going to be evaluated from 0 to 15. Okay. All right, so now let's plug this in. That's negative 1/3 times 15 cubed plus 5/2 times 15 squared plus 150 times 15 minus, and then what do? Now we plug the 0 in, right? But notice if you plug the 0 in, that's just going to be 0. Okay? And so when we plug this, we get 1,687.50. Well, let me rewrite that. That is, notice up here it says what? $100. So that would be $100. And so basically what we have here is the net excess profit is $168,750. That would be your net excess profit. And they ask you to interpret the net excess profit as an area, and we've already done that. That's right here. That's this area between the curve right here. That's this area here that we found. That's what they're wanting you to understand, that you are finding the area between two curves. Okay? That's all it is. And notice we did that. Notice what we did. We did the curve on top minus the curve on bottom. Okay? All right. Now we have the Gini index. It says if y equals Lx is the equation of a Lorentz curve, then the inequality in the corresponding distribution of wealth is measured by the Gini index, which is given by the formula. The Gini index is 2 times the integral 0 to 1 of x minus Lx dx. Okay? All right. So let's use that and let's do an application. It may kind of help us understand a little more what we're looking for. So it says a governmental agency determines that the Lorentz curves for the distribution of income for dentists and contractors in a certain state are given by the functions L1x is x to the 1.7 and L2x is 0.8x squared plus 0.2x respectively. So this one right here, they're saying this one is for the dentists and this one's for the contractors, because it says respectively, and the dentists were first, contractors were second. For which profession is the distribution of income more fairly distributed? Okay. All right. So, well, let's just set it up. So for the L1, we'll call that G1. That looks like a 6, but we'll call it G1 is equal to 2 times 0 to 1. Now, what was the formula? Come on down screen. It's 2 times 0 to 1. See, 2 times 0 to 1 of x minus Lx. So that's going to be x minus x to the 1.7 dx. So we just need to integrate this. So this is going to be 2 times, that's going to be 1/2 x squared minus x to the 2.7, add 1 to the exponent, multiply by the reciprocal of your new exponent, and we're going to evaluate that from 0 to 1. And so this is going to be 2 times, that's going to be 1/2 times 1 squared minus 1 over 2.7 times 1 to the 2.7 minus, and then we've got to plug the 0 in. So you plug 0 in for x here, 0 in for x here, and when you do that, you can see easily that that is 0. And so once you punch all that into your calculator, you get 0.2593. Okay, so let's just kind of underline that in red because we're going to have to compare that number with the number for the contractors. So now we got G2, that's 2 times 0 to 1 x minus Lx, which is 0.8x squared plus 0.2x dx. So remember, minus, put it in parentheses because it's minus the whole thing. And so let's distribute the negative. So that's going to be 2 times 0 to 1 x minus 0.8x squared minus 0.2x dx. I just distributed the negative sign. And so this is going to give me 2 times 0 to 1, and that is going to be negative 0.8x squared minus, is it minus? No, it's plus. Let me see. That's going to be plus 0.8x dx. Okay, so now we've got 2 times, that's going to be negative 0.8, that's x cubed, right? Add 1, divide by the 3, or multiply by 1/3, which is negative 0.8 over 3, plus that's going to be x squared, and that's going to be 0.8 over 2, and that's going to be from 0 to 1. Okay, and so now we're going to get 2 times, that's going to be negative 0.8 over 3 times 1 cubed, plus that's going to be 0.8 over 2 times 1 squared minus, and then we plug the 0 in, and notice when you plug the 0 in, that's going to be 0. And that is going to give us an answer of 0.2667. All right. So that's good and everything. We found that, but, well, what did we find? Well, since the Gini index for dentists is smaller, it follows that in this state, whatever state they're in, the incomes of dentists are more, let's see, more evenly distributed than those of contractors. So that's what we found. Because this value is smaller than this one, it means that the dentists are more evenly distributed. Okay? All right, now let's look at this. What do we have here? We've got the average value of a function. So the average value of a function, let f of x be a function that is continuous on the interval a to b, Then the average value v of f of x over a to b is given by the definite integral v is equal to 1 over b minus a times the integral f of x dx from a to b. So basically, to find the average value of a function, you're going to integrate the function with the bounds on it a to b, but you got to come out here and multiply by 1 over b minus a. All right. So let's look at this example. It says a manufacturer determines that T months after introducing a new product, the company's sales will be S of T $1,000, where S of T is 750 over T. 750T divided by the square root of 4T squared plus 25. What are the average monthly sales of the company over the first 6 months after the introduction of the new product? All right, so that's easy enough, isn't it? So V is equal to, we're going to find the average value, and they want to know what? From 6 to 0. We're going to evaluate from 0 to 6. And how do we know that? Because it says over the first 6 months. So from the time we start to 6 months later. So we're going from 0 to 6. And that's going to be 750T over the square root of 4T squared plus 25 dt. That's going to give us our average monthly sales. And so let's kind of rewrite this a little bit different. This is equal to what? 750 over 6 from 0 to 6 of t over 4t squared plus 25, and that's raised to the 1/2 dt. I'm going to be integrating, so I'm going to go ahead and change that square root to a 1/2 power. Okay, and the other thing I'm going to do is I'm going to write this as 125 over 8 from 0 to 6 of t over 4t squared plus 25 to the 1/2 dt. So what did I do? I just took the 750 over 6 and I reduced it. I'm sorry. 750 over 6 is 125. Okay? All right. I don't know where the 8 came from. All right. So all I did is I just plugged everything in, changed the square root to 1/2 power. 750 over 6 is 125, and now we're ready to integrate. So you can see this is going to be basic U substitution. So I'm going to let U equal 4t squared plus 25. So I'm going to get du is 8t dt. Okay. Now notice here, I've got to make my substitution. So for the 4t squared plus 25, see the 4t squared plus 25, I'm going to plug u into there. And then notice here how I have a t dt. You see that? See the t dt? What am I missing? I'm missing an 8. So I need to multiply this by 8. But if I multiply by 8, I have to also divide by 8. Okay? So, because then that's the same thing as dividing, as multiplying by 1. All right? So now I have 125 over 8. And that's going to be what? That's going to be 1 over u to the 1/2. So I put the u into here. And then the 8t dt. See the 8t dt, I'm going to replace that with du. Okay? And then I'm going to go from 25 to 169. Now, you should know how I got that, but in case you don't, let me explain. So notice what we did is our initial problem is in terms of t. And these bounds on my integral, those are t values, right? Well, what did we do? Well, we changed our variable to u. So now the bounds need to be u values. So I come over here and I have u is equal to 4 times 3 squared plus 25. So I'm taking the 3 and plugging it in here, and that's going to give me the U value. So that's 25. And no, wait a minute, let's see. I'm sorry. I'm sitting there looking at that thinking that's a 3. That's a 0. I've done messed up all kinds of stuff, hadn't I? So we plug the 0 in. And then I've got to plug in the 6. And that's equal to 169. And so that's where the 25 and the 169 come in. And so now I have 125 over 8. And that's going to be 25 to 169 u to the negative 1/2 du. Okay, so I just took that and moved it across the fraction bar, and that's going to change the sign of the exponent. So this is going to be 125 over 8, and that's going to be u to the 1/2. Negative 1/2 plus 1 is 1/2. Multiply by the reciprocal of your new exponent, and that's going to be from 25 to 169. And so now we've got 125 over 4. Okay, 125 over 4 times, and then I plug the 169 in. So that's 169 to the 1/2 minus 25 to the 1/2. And so that's going to give me 125 over 4 times 13 minus 5. Remember, raised to the 1/2, that's what? That's a square root. And so that's going to be 250. So the average monthly sales is what? 250. But notice, I think it said somewhere, yeah, it says the company's sales will be S of T $1,000. So that would be $250,000 per month. All right. So this one right here, this is our last example. All right. So it says a researcher estimates, I don't know why I put an X there, estimates that T hours after midnight during a typical 24-hour period, the temperature in a certain northern city is T degrees Celsius, where capital T of T is equal to 3 minus 2/3 times T minus 13 squared. What is the average temperature in the city between 6 a.m. and 4 p.m.? All right. So we want the average temperature. So the average temperature is 1 over something, and it's going to be 3 minus 2/3 times T minus 13 squared dt. We got to get the bounds. So it looks like we're going to go from 6 to 16. So that's 16 minus 6. Now, where did we get that? Okay, so we're in a typical 24-hour period. And so this is going to be in military time. So 6 a.m., well, that's 6. And then to 4 p.m. All right. Now, the 4 p.m. is 1600 hours. Okay. So that would be the 16 hours after midnight. I found an easy way to figure that out is, so if you have a PM, like 1 p.m. would be 1300, 2 p.m. would be 1400. So when you're in the PM, like 1 p.m., 2 p.m., 3 p.m., 4 p.m., and so on, you just add 12 to it. Okay. All right. So now let's go ahead. We've got, let's see, we've got, this is equal to 1/10, 6 to 16 3 minus 2/3 times t minus 13 squared dt. That's a 3 right there. All right, so all I did is 16 minus 6 is 10. I just took an extra step for that. Didn't have to, but I did. All right, so now this right here, notice how we have something in parentheses raised to a power. This one we could do use substitution. Yes, if you wanted to, you could write this as t minus 13 times t minus 13. Fold that out, distribute the 2/3, and integrate each one individually. And, you know, when I was looking at this problem to work, I worked through it by folding that out and integrating, and then I worked through it by just leaving it like this and using use substitution. I mean, both ways are going to give you the right answer, but I found that splitting these up and doing the use substitution, it just seemed less clutter. It wasn't so messy, and it just seemed like it was easier to work through. Whoop. So that's what I'm going to do. We're going to split these up. So this is going to be 1/10, and that's going to be 6 to 16 3 dt minus, okay, so that's going to be minus 1/10 times 2/3 integral 6 to 16 of t minus t minus 13 squared dt. So I pulled the 2/3 out, okay, or pulled out the minus 2/3. And so that's going to be 1/10 6 to 16 3 dt minus 1/15. So that cancels with that. We're left with a 5. 1/5 times 1/3 is 1/15. And then that's 6 to 16 t minus, why I keep doing that, t minus 13 squared dt. Okay, trust me, on something like this, take your time, write all the steps out. I mean, if you have to write an extra step just to do one thing, go ahead and do it. You'll be less likely to make a mistake. Okay. All right. So we have got 1/10 6 to 16 3 dt minus 1/15. Now here I'm going to do the u substitution. So u equals t minus 13. du is dt. So that's just a direct substitution. That's just u du, right? Oh, I'm sorry, u squared. Okay. Now we've got u is equal to 6 minus 13, which is -7, and u is 16 minus 13, which is 3. So we're going from -7 to 3. Remember, we're changing our variable, so we have to change our limits. All right, we've got to change our bounds on our integral. All right, so this is going to be, this is going to be 3/10t from 6 to 16. See, that's just 3t, right? When you integrate that, so that's just 3/10t minus 1/15 times, that's going to be 1/3 u cubed from -7 to 3. And so this is going to be 3/10t from 6 to 16 minus 1/45 u cubed from -7 to 3. All right, and you can see it hasn't gotten cluttered up. It doesn't look that messy, all because we chose to do u substitution instead of multiplying all that out and then integrating. So this is going to be 3/10 times 16 minus 6 minus 1/45 times 3 cubed minus -7 cubed. And when we plug all that into our calculator, we end up with -5.22 degrees Celsius. And so that would be your average temperature. And that is all of this video. So, you know, we did area between curves. That was the first several examples. We even had an example with a word problem where we actually found the area between two curves to answer our question. That was that excess profit problem. The excess, what was it? Yeah, the excess profit. And then we had some problems where we found the average value of a function, and we had a couple of word problems where we found the average value of a function. All right, so I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.